Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In this lecture, I will discuss remote terminal unit, RTU, and intelligent electronic devices, which are abbreviated as IEDs. The remote terminal unit has internal computational facility. It collects data from field devices, processes the data, and sends to master station through communication. It receives signals from master station and transmits to the field devices. So you can observe this thing over here. Here we have master station, and from the communication subsystem, uh, we have a bidirectional communication, right? Similarly, there is a logic substation and a termination subsystem. So this is communication subsystem, logic subsystem, and termination subsystem. And here we have a power system. And this whole thing is actually called RTU, remote terminal unit. So remote terminal unit has all these blocks, and here we have test HMI, and this is a power system. This is power supply. This power supply is used to power these three subsystems. Communication subsystem is an interface between SCADA communication network and RTU internal logic. So messages from master station are received and interpreted by communication subsystem. RTU initiates the requested control action, and RTU is responsible for interpreting the messages from the master station and formatting the messages in required protocol, including message security. So these are the tasks which are performed by RTUs, and communication protocols are used. Then we have message security, which is confirmed or ensured by parity check and cyclic redundancy check. Then we have a logic subsystem. It has central processing and control unit of RTU, data collection and processing, and internal control point selection. These are the tasks of logic subsystems. And here you can see this is a processing logic and a timekeeping. Timekeeping is a sequence of events logging or time tagging of events in power system, and synchronization with master station is also a part of timekeeping. So for this synchronization, GPS receivers are used, and 1 millisecond resolution is actually present. So whoever has been logged into the network uh, is actually called timekeeping. So the record of those logging or time tagging of events in power system is called timekeeping. Now, data acquisition and processing. So we have two types of data, analog and digital. Analog data is actually gathered by transducers connected to the field devices. And a termination subsystem is the third subsystem, and it is the interface between RTU and the physical world. It protects RTU from hostile field environment, surges, lightning, over voltages, electrostatic discharge, and electromagnetic interference. So these are the tasks of the termination subsystem. So this was a basic introduction of RTUs. Now we will move towards intelligent electronic devices, which are IEDs. So these are the devices incorporating one or more processors with the capability to receive or send data and control signals from or to an external source. Transition from RTU to IEDs. So as I told you in the previous lecture that RTU is the old technology, IED is a new technology. So transition has been observed from RTUs to IEDs in the industry, and IEDs have lower installation and panel assembly cost, shorter commissioning and maintenance times, shorter system recovery after a disturbance. So you can see here we have a substation server which is connected with the GPS, and these are intelligent electronic devices whose tasks are metering, monitoring, control, and protection. So IED can accept analog and digital data with selectable ratings, thus making the IEDs versatile. So IEDs are versatile. and they also provide protection function including phasor estimation. The protection function is the primary function of relay IED, as IEDs are primarily the improvement of the microprocessor based relays, and they are more accurate measurement devices. They have less auxiliary equipment. Different relay functions can be obtained from the same hardware just by modifying microprocessor programming. Isolation and analog signal scaling. Current and voltage waveforms from instrument transformers are required and scaled down to convenient voltage levels for use in the digital and numerical relays. Analog anti-aliasing filtering. High frequency components appear to be parts of the fundamental frequency components. So this filtering is also embedded into the IEDs, and analog to digital conversion is also present in IEDs. Phasor estimator algorithms. Phasor estimation means measurement of amplitude and phase of waveforms. System monitoring is another aspect which has time synchronized from a common GPS source. And phasor measurement unit, which are PMUs, they are also embedded in IEDs, and programmable logic and breaker control. This is also present in IEDs. PLCs are not required separately. Inputs and outputs can be connected to flip-flops and gates directly. Metering and power quality analysis is another aspect. Event reporting and fault diagnosis, self-monitoring and external circuit monitoring, programmable LCD displays. So these are all the features and components of a SCADA system, and I hope you have understood these basic and simple concepts of the SCADA system. So I agree that all the things which we have discussed in the SCADA section are theoretical information, and for more details of the SCADA system, we have to visit the industry where SCADA system has been installed and different modules and devices can be inspected and analyzed in that working environment. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.